So let's look at the constraints. So we have the assembly labor constraint and testing labor constraint, how much we need for the basic model, how much we need for XP model, and how many hours are available. And we also have the maximum sales possible for base model and XP model. Okay, we're going to now draw lines that represent these constraints. So let's look at our graph with x sub 1 represented in x-axis is the number of base model computer, and x sub 2 represented in the y-axis is the number of XP models. So let's take the assembly hours constraint, which is 5 hours as assembly needed for each base model. So that's the total assembly hours needed for base model, and 6 hours needed for each XP model. So 6 times x sub 2 is the amount of assembly labor needed for XP model. So these two, the additive properties of these two when added, gives you the total assembly hours that we will be using, and that has to be less than or equal to what is available in 10,000. Now if we set this equal to 10,000, then we can draw a line along this graph, and to do that we will set one of the two variables to 0 and use the entire 10,000 for the other model. So like if we don't make any of XP, then we can make 2,000 of x sub 1, the base model, and that will use up all of the 10,000 hours. So that represents 1 point. If you do the reverse with not produce any base model but produce only XP, and that will be 1666.67 1666.67 hours units of XP model. That will use up all of the 10,000. Okay, of course we cannot make 0.67 of a computer. It has to be either 1666 or 1667. But then remember, we had this, we're going to be looking at some properties later where the divisibility of the decision variables is a required prerequisite for LP modeling, and that is the decision variables can take all values in a continuous number line. Okay, so any integer and non-integer. So if you want to restrict it to only integer, we have to do it in a different way. We have to set it up in a different fashion. We will do that later. But for now, let's ignore this problem and let's get the basic concepts understood. So now if you connect these two, like in the objective function line, it represents all the combination of x sub 1 and x sub 2 values that will use up all of the 10,000 hours of labor available. And of course all the points below this line will also be feasible because you'll be using less than or equal to 10,000 hours. But any x sub 1 and x sub 2 value combination that falls outside here is not possible because that would require more than 10,000 hours of labor. Now this is not the only constraint, so let's now bring in the testing labor constraint, and we need 1 hour of testing labor for basic computer, 2 hours for XP. So this expression will give you the total testing hours we will use, and that has to be less than or equal to 300. Let's plot this line again by setting this expression equal to 3000, not produce any XP at all, would give you x sub 2 as 0 and x sub 1 is 3000. So that's 1 point. Then set x sub 1 to 0, then x sub 2 will be 1500. So that's that point. Now connect these two. That's your second constraint. Now all points below the blue line will satisfy the testing hours constraint, and points above the line will violate the testing hours constraint. But remember, we have to satisfy all the constraints, not just one at a time. So here these points are okay with respect to the blue line. It's feasible for blue line but not for green line, so we have to eliminate these points. Now, these points are feasible for green line but not for blue line. So these will have to be eliminated also. Of course, the points here are not feasible for either of them. So right now, with just these two constraints taken into account, the points below the blue line up to this point and after this intersection, points below the green line are the ones that are feasible. Of course, both x sub 1 and x sub 2 must be greater than or equal to 0, non-negative. Now let's bring in the maximum allowed sales constraint. Okay. The first one is maximum allowed basic model sales of 600. So x2 doesn't even come into the picture here. So x sub 1 equal to 600, okay, and a line going straight up will represent that constraint. So that is x sub 1 equal to 600, and the constraint goes right up, and that further restricts the feasible region. So now all of these points below the green line that was previously okay are now eliminated. So at this point, the feasible points are only represented by this box. Okay, below the blue line, below the green line, and then to the left of the red line. Now let's look at the maximum sales constraint for the XP model, which is x sub 2 is less than or equal to 1200. So let's take x sub 2 equal to 1200. Now all points below that is feasible, so you can draw a line, horizontal straight line. So all points below that are feasible. So now the feasible area has gotten further restricted to this. Okay, here is the first constraint, assembly hours. This is the second constraint, testing hours. This is the maximum sales constraint for basic model. This is the maximum sales constraint for XP model, and that gives us this as our feasible range or feasible region. All points in this area are feasible for all the four constraints. Now here you notice that the blue constraint, which is testing hours, is outside the feasible region. So that means this line is redundant. So this is a redundant constraint, so you can just remove the constraint. It doesn't matter because feasible region is inside it. The blue line is outside the feasible region. So we can throw it out. So now we have to find the optimum solution. So we now bring back our ISO profit line. Okay. Now we can now increase the ISO profit line, and we want to do that as much as possible but not leave the feasible region, because once you leave the feasible region, then there is no point on the ISO profit line that represents a feasible point. So we need to increase this only to the extent that is you up to the point that you're still touching the feasible region and you have not left the feasible region completely. So this is the point that the maximum profit that is possible. That is, you're able to move the profit line to the maximum as only when it touches that particular point. So that point is our optimum solution. That represents the optimum solution, and that is an intersection between the purple line and the green line. So we need to look at the intersection between the purple line is x sub 2 equal to 1200, and the green line is assembly, which is 5x sub 1 plus 6x sub 2 equal to 10,000. So with these two, now we can solve. Okay, x sub 2 is 1200. You substitute x sub 2 here with 1200, and you solve for x sub 1, and you get 560 for x sub 1 and 1200 for x sub 2. So we make 560 units of basic and 1200 units of XP, and that will give you the maximum profit. So plug in 560 and 1200 in the profit line. okay, and you get the maximum profit. So our solution is make 560 basic model, 1200 XP model, and you make a profit of 199,600.